Good afternoon, my students. Lesson 53, Algebra 2. Are you ready? I'm pumped. Gracie is lying at my feet. We're ready to go. The topic for lesson 53 is unit conversions. We're going to start with metric unit conversions, which are the easiest. Example 53.1. Use unit multipliers to convert 7,560 centimeters into kilometers. All right, you may not be super up to speed on your metric units. We'll figure that out as we go. Make some notes in the front cover of your homework notebook if you have a hard time remembering them. It's fine. We're going from centimeters to kilometers. Centimeters, you know, are usually on rulers. Kilometers are how most of the world measures miles on highway signs. So that gives you a little bit of a visual. We're going to do it in two jumps. In the first one, we're going to go from centimeters to meters. A centimeter is small. A meter is like a yardstick. We want centimeters on the bottom, so it'll cancel. Meters on the top. Meters is the bigger one. Remember, it's like a yardstick. A centimeter is like your knuckle. There are 100 centimeters in 1 meter. The prefix centi means 100, like century. You got it. Okay, so now our centimeters cancel. In our second step, we want to go from meters to kilometers. Kilo means 1,000. So, here's our meters up here, so we want our meters down here. Kilometers are up here. Kilometers are bigger, and as our little note here tells us, kilo implies 1,000. So, our meters cancel, our centimeters cancel, we're left in kilometers. Yay, that's what we want. So our answer (7,560) times 1 times 1 over 100 times 1,000. Now, here comes the magic of centimeters. Every one of these zeros represents a decimal hop. We have to figure out if it's a decimal hop that makes our number bigger or smaller, but then we just start jumping our decimal and it's super easy. Because we're dividing by these numbers, we're making our original number, 7,560, smaller. Every zero represents a jump. 1, 2, 3, 4, 5. So here's our decimal. 1, 2, 3, 4, 5. So that's how many, I'll write it again, 0.0756 kilometers is the equivalent of 7,560 centimeters. That's so much easier than dealing with feet and inches and all of that nonsense. That's why we love the metric system. Let's do another one. 53.2. This time we're going to use 2 unit multipliers. John is nice enough to tell us. And we're going to convert 15 million, good Lord, 740,000 square centimeters. Okay, so I'm going to write it twice so I can cancel it out. To square kilometers. Oh, it doesn't say 2 unit multipliers, it just says unit multipliers. Okay, well, this is the very same adjustment that we did last time. We're simply moving in squares instead of linear measurements. So what I'm going to do is, I know we're going to use the same 2 measurements, but we're going to have to double them up because we're going square. I'll put 2 there as well. So our first one, we know, I'll write my things up here, my map, since I don't have really room underneath. We're going from centimeters to meters, centimeters on the bottom, meters on top, 1 meter for every 100 centimeters, cross, 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 yay. Now we need to go from meters to kilometers. We want our meters on the bottom, kilometers up here. Kilometers are bigger, they get the 1. Meters, oh yeah, 1,000. Kilo means 1,000. Okay, and now our meters cancel. And we're left with 2 kilometers. That's exactly what we want. Yay, we did it. Now we just have to summarize. It's this big giant number over a pair of 100s and a pair of 1000s. Let's get it. 15,740,000 over 100 times 100 times 1,000 times 1,000. We know every zero represents a decimal hump. We know that we're making this number smaller because we're dividing by all that. Write out 15740,000 without the commas because we're going to be changing all that. The decimal starts here. Now let's count our jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the new decimal, a pair of zeros to fill in, and our final answer is, I'll put a leading zero just for fun, 0.001574, and now we can drop off all those zeros because they're not significant in decimal world. And this is kilometers squared, and yay, that's the right answer. Okay, so this is part A, and what we have been doing is converting metrics to metrics. Now in part B, we're going to convert the dreaded English units, the inches, the miles, the feet, the yards. We're going to convert English units to metric units. Now, here's the way I want you to envision this. Here's the world of English units. Like I said, there's inches, there's yards. I'm not listing these in any particular order. There's feet, there's miles. Those are just the linear measurements. We've got quarts and pints and all that nonsense too. But right now we're mostly staying focused on linear measurements. And then over here in the metric world, we have centimeters and meters. Whoops, that's an extra bump. Kilometers. Those are the ones we've been talking about the most. There is one portal, one way to link those two worlds. There really isn't, but that's what I want you to imagine. There's one link. This is a tunnel that we can crawl through to get from one world to the other. And this link is based on the fact that 1 inch equals 2.54 centimeters. We're always going to use this equivalent as the way to translate back and forth. So whatever unit we're starting with over here, say on the English side, we want to convert it to inches. Then we'll bump it over to centimeters, and then we'll adjust it to meters or kilometers if need be. Same thing if we're starting over here with our English units. We're going to get it to centimeters, because then we can use our magic link, and then we'll be on the English side, and we can adjust as need be. Okay, let's see how it works. Flippy doodle. I just have to check and make sure I'm still in the frame. Okay, so the first one, example 53.3. Use unit multipliers to convert 32 yards to meters. Okay, so we're starting with 32 yards and we want to go to meters. All right, let's plan it out. We have to get to that inches to centimeter because we're going from English to metric. So, in this first one, let me draw my boxes first. In the first one, we're going to go from yards to inches. If we weren't sure how many inches are in a yard, we might have to go from yards to feet to inches, but we're going to be bold and do it in one jump. We'll deal with that in a minute. Then once we get to inches, now we're going to transfer between the worlds. We're going to go from inches to centimeters, and now we'll be in the metric world, and we'll go from centimeters to meters. Okay, so there's our roadmap. Are you ready? We'll put that over 1. Here we go. We want yards on the bottom, inches on the top. A yard is bigger. Visualize a yardstick. How many inches are in a yard? Well, we might have to go, there's 3 feet in 1 yard, and then there's, for every 1 foot, there's 12 inches. That will help us see, 12 times 3, there's 36 inches in 1 yard. If that blows your mind, just find a yardstick and look at how many inches are on it, and you'll see 36. Googling works as well. Excuse me. Okay, so yards are gone. We're in inches. All right, now we're ready to transfer between the two worlds. Inches on the bottom, centimeters on top, and we remember that 1 inch equals 2.54 centimeters. Oh, that's such an ugly little number. I'm sorry. There's no way I can make it that pretty for you. Inches cancel. Now we're in centimeters, and we want to go to meters. Remember, centi means 100. So there's 100 centimeters for every 1 meter. Centimeters cancel. We're in meters. That's what we want to be in. Yay, we did it. Now let's write down the answers. 32 times 36 times 2.54 all over 100 meters is our ending unit. And I'm double checking. 32. They did 3. John did 3 times 12 instead of 36. That's the same. We're cool. 2.54. John also puts the ones in. I'm not a fan. This is the correct answer. And notice that we're back to the mess of not being able to easily finish the calculations. When we were in just meters, we can just jump our decimal point and everything's fine. But English units send us into crazy land. So this is the final answer. We don't have to go any further. Okay, this is the portal, the magic portal that gets us from the world of English units to the world of metric units, or vice versa. And that 2.54 centimeters equals 1 inch. That is the magic equivalent that we need in order to climb through that little tunnel. I'm climbing with my hands. I don't know if you can see that, but I'm literally climbing through that little tunnel. Okay, let's do one more of these. Example 53.4. And in this one, we're using unit multipliers to convert 0.042 square kilometers, we're going to need 2 of them, to square miles. Oh, Lord. Super real life, though, because so many countries measure their distances in kilometers, and in the U.S. we use miles, so it makes sense that we would actually need to do something like this from time to time in the real world. I'm going to put that over 1. Okay. We need to go from kilometers, let's go to meters, because going from kilometers all the way to centimeters would be quite a leap. Now we'll go from meters to centimeters. Okay, that's the portal. And centimeters to inches. Oh, I'm going to have to go to a second row. Pretend that I'm going on. But I have to do a second row, because this is quite the journey we're making. Okay, so now we're at inches. We need to go from inches to feet, because I don't know how many inches are in a mile. So we're going to have to go from inches to feet, and then from feet to miles, and then that will get us to there. So I'm going to erase that and put it down here. Miles, miles. Whew! Okay, here we go. So this is all being multiplied. I could have opened my book, but then it wouldn't have fit in my camera, so oh well. All right, kilometers on the bottom, so they cancel. Oh, and P.S., because this is square, we're having to do all of these twice. So with each one, I'm going to write 2 times above it to remind us that because we're dealing with squared units, every one of these adjustments has to be done 2 times. Lord have mercy. Okay, kilometers to meters. We have to do it twice. So there's my double cancel. A kilometer is bigger. How many meters are in a kilometer? Kilo stands for 1,000. So 1,000. Cool. Meters, and this is twice. I'm going to write it twice. I'm going to write that one twice as well. Meters, meters, centimeters, centimeters. There's 1 meter for for every 100 centimeters. So now this is canceling against this. This is 2 times. And there are my 2 centimeters. That's what we've converted this to. Now we need to go from centimeters to inches. Okay, here's the portal. Again, we have to do it 2 times, just like every other one. Centimeters on the bottom. And the portal will adjust us to inches on the top. Inches are bigger, so there's 1. Centimeters, the magic number is 2.54. We are doing it twice, according to this notation. So now we've got it adjusted over to inches. Well, that is quite an accomplishment, isn't it? Again, we've crawled through the portal. I'm crawling. So now we're in inches. So now we're ready to go from inches to feet. Inches are on the top here, so we want them on the bottom here. A foot is bigger, so it gets the 1 inches, 12 inches in a foot. These inches cancel against these inches. We're currently in feet. Oh, you guys, we're almost there. Feet on the bottom, miles on the top. Miles are bigger, so that gets the 1, 5280. So how many feet are in a mile? Oh, our journey is almost complete. Miles, oh, let me cross them off against this. That's what we, or no, I wanted to circle them. We're not canceling it. That's how we want our answer. Everything is glorious. Now we have to write this all out. And it is going to be quite a number. So we start with 0.042. We multiply it by 1,000 squared, because it's 2 times, times 100 squared, because it's 2 times. I'm not going to do the 1, and then 1 and 1. So that's everything in the numerator. Now the denominator, 1, 1, 1. Okay, here's 2.54 squared, because it's 2 times. And 12 squared. Oh, I forgot to write this here. 2 times and 2 times. So we square the 12, and then 5280 squared. Because it's 2 times. That gets us to miles squared. Oh, I dare you to do that math in your head. Not that we should even try. Okay, and then we look at the answer, and it is giant, because John has written each of these out twice, and he's also put in the ones. So I'm going to double check. 0.42, 1,000, 1,000, 100, 100, and then a bunch of ones. And then down here, he has a bunch of ones, and then 2.54 twice, 12 twice, 5280. Yay, that's the right answer. It's kind of a lot, isn't it? But don't you feel really smart looking at all of this and going, okay, yeah, that kind of makes sense. The important thing, and that's right here, is where we climb through the portal. It's very Doctor Who-ish. And I don't know if that's a good thing or a bad thing for you, but I kind of like it. Okay, that is part B, where we go from English units to metric units. Part C is completely unrelated. I don't know if that's bad or good, but I think it's good. C, weight combination by percent. Oh, this is super tiny adjustment to something we've already been doing. It's chemistry related. Okay. Here's the question. Example 53.5. What percent by weight of this chemical, Na2S2O3, is the sodium? Okay, so what we have to do is we have to figure out how much this combination, this molecule weighs, and then we have to figure out how much of it is that, and then we will find that as a percent. Okay, so I'm going to make a list. This one, this one, and this one. I'm pretty sure that's sodium, sulfur, and oxygen. Yeah, John tells us that. Thank you, John. Okay. And then we're going to need a total eventually. All right, first we need to know the number of atoms in our recipe of each of these. This is what we've been doing. The number of atoms, oh shoot, I wrote my total in the box. Okay, so this is a 2, right? We have 2 sodiums, 2 sulfurs, and 3 oxygens. Okay, now I'll move my titles up where they belong, up above. Then we need to know the weight, the atomic weight, and this is what we get from the little note John writes at the end of the problem. And in this one, he doesn't write it down there because he writes it in a different part. He tells us that, I'll write it down here, Na23, S32, O16. You know how he always writes that at the end of the problem? He's still doing that for us, although in this presentation in the book it just gets a little scrambled. Okay, so the weight, make that a wider column. The sodium weighs 23, so when we multiply it by 2, we get 40. Oh no, I'm just going to write this. 23, 32, 16. Now we multiply it. So this is now the molecular weight. In other words, how much this particular compound weighs in this molecule of weirdness that we're making. So 2 times 23 is 46. 2 times 32 is 64. 3 times 16 is 48. Now we can find a total. 6 and 4 is 10 plus 8. I'll say that's 18. And this is 10 plus 5 is 15. Okay, so this is how much the whole thing weighs, and we want to know how much by percent is the sodium. So it's as simple as saying, well, the Na equals sodium equals 46, and the total is 158. So we simply divide 46 by 158. And let's see, we're going to need a decimal, and we're going to need a 0, and I'm thinking that doesn't quite go in 3 times. I think it goes in just twice. 6, carry the 1. 2 times 5 is 10, plus 1 is 11. 2 times 1 is 2, plus 1 is 3. We subtract 4. Gosh, if you guys were with me, I would be asking you to do it. Okay, yes, so it went in only twice. It's close to going in a 3rd time, but not quite. I'm going to guess 9. 9 times 8 is 72. 9 times 5 is 45, plus 7 is 52. 9 times 1 is 9, plus 5 is 14. Oh, I didn't write this properly. This should be like that, and then bring down a 0. Okay, and so I subtract. I like my estimate. That worked out really well. 3, 8, 18. And so I know that it's going to go in one more time there, but I'm going to stop, and I'm going to say that our answer is that the Na, the sodium, equals 29%. And that's the correct answer. So this is the hardest part, honestly, of this whole problem. This we're used to doing, setting up this table, and what we simply did was took the weight of the one we're interested in, the sodium, and we created it as a fraction over the total, and then we just did the grinding of finding the answer. So there's the weight of the sodium as a percentage of the total. I know, it's riveting. I loved it too. That is the end of lesson 53. I'll see you soon for 54.